Hi everyone. So this is a tutorial discussion for the ranking cycle. If you refer to the ITELs, let me show you. I think I have shown you previously. If you refer to the ITELs and then you go to the ranking cycle, and then you go to our lecture on the last part, there is a question. Can you see here? Right. So the question asks, a steam power plant operate between a boiler pressure of 42 bar and a condenser pressure of 0.035 bar. Calculate the efficiency, the work ratio, and the SSC. If they is at the Carnot cycle using wet steam, then Rankine cycle. Rankine cycle when the expansion has isentropic 80%. Compare the performance compare the performance. So in the class I have discussed, but some of you say the slide is a bit too far, it's not clear for you. So I'm going to repeat one more time. Hopefully you can be much clearer for you. So for this ranking cycle, you need to prepare the steam table A5, A5, A4. Okay, so okay, the Carnot cycle use wet steam. If it's Carnot cycle, it's basically a square cycle. So P1 equals to P4 42, P2 equals to P3 is the lowest pressure. Well, you can label the other way around, make sure you don't do the mistake. Is it all right? So because it's steam, we refer to the steam table A5, which is this one. All right. And as you refer, the pressure is given. So we refer to the pressure table. Okay. So then from there, you do the interpolation. If you're not familiar with the interpolation, you can refer back to our, I think it's tutorial online version, this part to further practice on how's the interpolation. And also can check out how to read the steam table. It's okay, that is the fundamental part. So if you refer back to the previous curve, we know that actually the pressure table is like this for the steam. It is actually like this. Okay, so means that the pressure, okay, the pressure, this is the pink color is the pressure line. And then the temperature of T4 equals to T1 because they are in the same, because this one is the TS diagram. So T3 equals to T2. Is that all right? So to find the T1 and T4, you do the interpolation by refer to the table of A5. So the question asked is 42 bar. So 42 bar is 4,200 kilopascal. So it's between these two. So you use these two line to find it out. Okay, to get the temperature. So as the T2 and T3, but the T2, T3 is you have to refer to the low pressure to do the interpolation. So once you have the high temperature and high temperature and low temperature, then you can find the efficiency, Carnot cycle equation. And the work ratio is the net work output over the gross work output. Okay, so let's check out what is the network output. The network output is the what is the network output? What is the network output? Let me check. Let me delete this one. Okay, so the network output over Q in equals to the efficiency. So just now we found the efficiency, okay? And Q in equals to H1 minus H4. So this is Q in, right? Okay, so, and you know that Q1, H1 minus H4 is the HFG because it's, you know, it's located between the saturated curve. So what you can do is you refer to the 42 bar, 4,200, let's say 4,000. So the HFG, it should be between 1,639 and 1,713. It's between that. You have to do some interpolation. And then you have the Q in, you have the efficiency, and you can get your network. Well, I also give you the way how to do the interpolation. Check it out, your answer with mine. And then for the gross work output, refer to the note. It should be H1 minus H2. So, and again, H1, we know that this is the Hg, it's a gas form. From there, because the isentropic gun is isentropic, so we also use that to find our S1. Because this is a S table, S1 equals to S2. Then I borrow the S1 value. Basically, S1 equals to S2 ma. Then I refer to the pressure, the low pressure, 35 kilopascal. Then now I use 35 and I refer to the S, okay? And after that, I can find my dryness ratio, dryness factor, okay? So then use the dryness factor, and then I find the H2. Okay, is it okay? So how to do this? Again, if you're not familiar, refer back to the ITELs. There is some YouTube over there. So we have the gross work output and we have the net work output, and therefore we can get our work ratio. So for the SSC, it's 1 over net work output, so it's very straightforward things. So the Rankine cycle with dry saturated steam to enter at the turbine. So repeat, Rankine cycle with dry saturated steam to enter the turbine. And again, you have to familiar with the process, right? So dry saturated steam to enter the turbine. So which part is the turbine? So you have to check this one first. Right, because it's dry saturated steam. So from 2 to 3, okay? So previously for the Carnot cycle, it's hanging in between. But I want to have dry saturated steam. It further move and stick on the 3 stick on the saturated curve. So from the, if you compare to the curve, the figure 1 and the second figure, it seems like 1 to 2, the value we can use it again. The difference is 3 and 5 should be the same as the 4, okay? So we can use 1 to H1, H2, and H3 is pretty straightforward because it's gas, a fluid. So so you have to refer to the HF at the low pressure, then you can get the value. So, and then H1 minus H2 minus H4 minus H3. If you have the feed pump, okay. So if you don't, you can ignore it. And then we have to refer back to the question. is the question. Okay. Saturate at the entry to the turbine. So not this one. Okay. So the Rankine cycle efficiency is H1 minus H2 minus H4 minus H3. The pump work, you can also refer to the specific volume times the pressure 4 minus P3. And if you look at the graph, right, P3 equals to P2, P5 equals to P1, and P4, P5, P1 is same pressure. Is that okay? So means that what is if you want the specific volume, so you have to refer to the low pressure and then refer to the table. How? This one, specific volume. Okay, so let's say it's 3 kilopascal and it should be VF. Okay, why VF? Because it's stick on the saturated line. All right, and then so then you have your H3 minus H4 equals to 4.3. Because you know the pressure P4, you know the pressure P3, right? So the P4 is say same with P5, same with P1 is 42 bar. P3 equals to P2 equals to 35 kilopascal. Okay, so and then you plug in there, you can get your feed pump, feed pump. And then for the others, actually you can quite pretty fast to get all the value, and therefore you can get the efficiency. So the work ratio, the net work is Q in minus Q out. Okay, so you can refer back to the gross minus the feed pump over the gross, and you can get your work ratio. And for the SSC, same thing, 1 over the net work. Okay. So the cycle with reversible expansion, and it's equals to 0.8. So then means that we need to find the actual TA. So by refer to this equation, okay, so then you should able to find your H1 minus H2A equals to this value. You know the H1, right? So you quite easy for you to find the H2A. Okay? But you don't need that because you need H1 minus H2A to put in the equation here. And H1 minus H3 is pretty straightforward because H3 is stick here. So you just need to find the HF at the low pressure. Plug everything in, you can get the efficiency. Same thing with this. And then compare the performance. Which one is better? It's quite straightforward. Okay.